Good morning or good afternoon, as the case may be. My name is Sosale Mohana. I'm a maths teacher who has taught maths for over 50 years in 3 continents and 3 countries, like India, in Asia, Kenya in Africa, and England in Europe. I've just retired a couple of years ago, and I thought I should use my experience to record and deliver a number of lessons based on the British curriculum for A-level maths, so the students who want to reinforce their learning can use it. I have a master's in maths, of course, way back in 1969. I completed my master's in maths, and then I did my teacher training in 1974. I've been working since 1969 till 2019, clear 50 years. So I hope these lessons are useful to you, and you're welcome to watch them, and then with each lesson there will always be a document which covers whatever has been done in the lesson, so you could use that perhaps as your own notes, or maybe to go over what has been taught during the lesson. I hope you enjoy the lesson. Hello. In the last lesson I talked to you people about verbal questions in quadratics, and then we went on to inequalities. So today we are now going, so far we have done quadratic equations. So now we go to a discussion of quadratic functions. So we are still in basic algebra. So the topic is still basic algebra. And today we will discuss quadratic functions. This again is AS. Basically, in the first 2 weeks or the first term of A level, you will have learned this. In some cases, you will have learned it in GCSE as well. So the function y equal to ax squared plus bx plus c, where a is not equal to 0, is a quadratic function. And the quadratic function, when you draw a graph, represents a parabola. What's a parabola? Is something like, you have a double cone. And if you were to slice it right in the middle along the line of symmetry, the one piece will look like this. That piece is a parabola. They're called conic sections. Of course, later on, if you do further maths, you'll learn more about how these things are generated. But the easiest way to remember is a U-shaped graph. A parabola is generally a U-shaped graph, and it has been used for a long time in signaling, in trying to, in astronomy as well, and in observatories and so on. And of course, some of you might have, you have heard of the Halley's Comet. Halley's Comet has an elliptical path, meaning it goes round and comes back roughly every 72 years or 80 years. So generally, based on our life expectancy, a person who sees Halley's Comet in his life may not be able to see it again. Whereas there are certain comets, I think it was, when I was young, I think it was the Ikai-Soki, I'm not too sure. It came once and then it went back. It's a parabolic path. That means it comes from one end of the universe, goes around the sun and goes to another end of the universe. It's called a parabolic path. So anyway, that's just out of interest. So a parabola, the shape depends upon the value of A. The shape meaning, the orientation. It could be a cup. In other words, look, a parabola could be like this, or a parabola could be like that. So that depends upon whether x is, the coefficient of x squared is positive or negative. If it is negative, then it is a inverted cup. I prefer using cup and cap. Some people prefer using U and N. I prefer using cup and cap. So if A is negative, it's a cap. If A is positive, it's a cup. But then, say a quadratic equation, when you draw the graph, it could be perhaps like this, or it could be like this, or it could be like this, or it could be like this. They're similar but not identical. Or it could be funny like this, or like this. In other words, it cuts the x-axis in 2 points in both cases. It touches the x-axis in 1 point, or it does not cut the x-axis at all. There are 3 possibilities. To understand this, let's look at the formula we used. X equal to minus b plus minus root b squared minus 4ac over 2a. B is a number, so we know the number. 2a is a number, so we know a and 2, no problem. We know what is positive, what is negative as well. But this root is only defined if b squared minus 4ac is positive. B squared minus 4ac is a number. It could be 0, it could be negative, it could be positive. So in other words, if it is 0, then what will you get? You'll get minus b over 2a plus 0, minus b over 2a minus 0, meaning both roots are minus b over 2a, which means there's only one root. But a quadratic is supposed to have 2 roots, so both roots are the same. We call them as equal roots. That happens here. This is b squared minus 4ac equal to 0. If b squared minus 4ac is negative, square root of minus 4, at your level, you don't have the answer. Later on, when you do further maths, we assign an answer using a complex number. At the moment, no answer. That means there is no value of x for which y is 0. Therefore, it's not going to cut the x-axis, so that will be the graph. Oh, I should have written here. So obviously, even otherwise, we have done both cases, negative and 0, so the only case left is positive. Here, I can have 2 sub cases. Maybe this is 1, this is 4, minus 1 and 4, or maybe this is 2, that is 3. But it's also possible, let me rub this off. It's also possible the graph is somewhere like this, and the graph is somewhere like that. This is square root of minus square root of 5, that is 3 root 5. This perhaps is root 6, and that is 2 plus root 6 or something. How do you know whether the root is going to be whole numbers like this or surds like this? That depends upon it. Number 1, b squared minus 4ac must be positive. Number 2, if it is a perfect square, that means b squared minus 4ac is x squared, y squared, 4 squared, 6 squared, 36 squared, 15 squared. Then you get roots that are not exactly integers. Maybe I shouldn't put this, maybe 2 over 3 and 3 over 5. You get rational roots. So for it to have a rational root, b squared minus 4ac must be a perfect square, or square root of b squared minus 4ac must be rational. Otherwise, you get surds. So everything, the concept of what kind of roots you're going to have, you don't have to solve. Just looking at this, looking at b squared minus 4ac, you can decide what kind of a graph you're going to get, what kind of roots you're going to get. That's how that b squared minus 4ac is the most important part of a quadratic equation. It's called the discriminant of the quadratic. Of course, please understand, a cubic also has a discriminant which is beyond you and any other equation, 4th degree, 5th degree, but we're talking only discriminant of a quadratic. So b squared minus 4ac is called the discriminant of the quadratic. It discriminates among the types of roots. B squared minus 4ac positive and root of b squared minus 4ac is rational. Then you get real, distinct and rational roots. If b squared minus 4ac greater than 0 and root of b squared minus 4ac irrational, means you get real, distinct surds as roots. B squared minus 4ac equal to 0, you get equal roots, double root, we use so many names, only one root, only one real root. For the quadratic again, everything is to do with the quadratic. Or what else do we call it? Perfect square. I mean ax squared plus bx plus c equal to 0 is a perfect square. For that, b squared minus 4ac must be 0. So therefore, ax squared plus bx plus c equal to 0 has real roots. Once they say it, it means b squared minus 4ac greater than or equal to 0. So all these four cases add up to, these three cases add up to it's having a real root. But if b squared minus 4ac is less than 0, imaginary roots. If you don't want to write imaginary roots, you can write no real roots. As I said, you don't have to copy the notes because you're going to get a handout along with this which has all this information. So, the nature of roots of a quadratic equation can be decided by looking at the value of the discriminant. So, that also tells you whether it's going to cut in 2 points, whether the x-axis is going to be tangent at a point, or the graph is completely above x-axis, completely below x-axis. Also, whether it's a U, a cup, or N, a cap, depends upon whether A is positive or A is negative. That's the reason why I did inequalities before this, so that when we do questions, we're going to use this concept plus solving inequalities, which we'll do in the next lesson, applications of discriminant. Thank you very much. Hello. I want to take this opportunity to propose a vote of thanks. I would like to thank Vivid Innovations Private Limited and Commerce Forum for so generously giving up their studio and the facilities and the services of their technicians to record all these videos for free. I think that needs to be acknowledged and appreciated. Thank you very much. And my special thanks to Mr. Nitin Mahadevappa, Mr. Nishant Guruswamy, and Mr. Sadan Kumar DN for all their help and assistance in getting these videos ready, uploaded and launched. Thank you very much.